question is solution. Let me solve it here. Question number 7. Left hand side we are taking tan 70 degree. Now tan 70 degree, we can write it as, this is left hand side here. Tan 70 degree can be written as 50 degree plus 20 degree. This is nothing but tan A plus B formula, tan 50 degree plus tan 20 degree divided by 1 minus tan 50 degree into tan 20 degree. Okay, this is equal to tan 70 degree. Alright, if I cross multiply this, let me cross multiply this. This implies that tan 70 degree into 1 minus tan 50 degree into tan 20 degree is equal to tan 50 degree plus tan 20 degree. This is the value. Now let me open this. This is tan 70 degree minus tan 70 degree into tan 50 degree into tan 20 degree is equal to tan 50 degree plus tan 20 degree. Okay. Now, if I take tan 50 degree common, twice of tan 50 degree it is coming. Twice of tan 50 degree. Okay. Twice of tan 50 degree is coming. You know, tan 70 degree, tan 50 degree. Now tan 50 degree and tan 50 degree, if I take common out of these two, well, therefore let me take tan 70 degree is equal to that side. This is tan 70 degree okay. Now if I substitute here the value of tan 70 degree, which is this, okay, or I could do that. Okay, let me just take it. Tan 50 degree, okay, let me take this to that side. It will be positive that side. It will be tan 70 degree, okay, into tan 50 degree into tan 20 degree plus tan 50 degree plus tan 20 degree. Also these two, tan 50 degree is common. We take tan 50 degree common. It will be 1 plus, because tan 20 or tan 70 degree plus tan 50 degree we have to take, no problem. This is tan 50 degree plus tan 20 degree, twice of that will be left over. For the tan 50 degree, this is 1 plus. It is 1 here, tan 50 degree plus tan 70 degree. Okay, and tan 70 degree into tan 20 degree. Out of this tan 50 degree, this is 1 we have taken, and out of this tan 50 degree, tan 70 degree plus tan 20 degree. Okay. Now tan 70 degree we have to prove that this is equal to 1 plus tan 75 degree, 70 degree and into tan 20 degree. Tan 50 degree. Now how this is equal to twice of this, because it must be equal to 2. This is twice of tan 50 degree. And if I put tan 70 degree, that value, so that can be substituted there. it must be equal to twice of this, then tan 70 is twice of tan 50 degree, and plus that. Okay, and we have just taken tan 50 degree upon 1, tan 70 degree and minus tan 70 tan 50 degree. Okay, so something complicated question, no problem. With tan 70 degree we are forward. Tan 70 degree, this is equal to this tan 70 degree, tan 50 degree we have taken from these two points. Okay, but it means this value is coming as twice. If I have to prove this twice of this value, now let me check that. Okay, that will be better. If that is equal to 2, then it value. Okay, let me take this in this way. That this is tan 70 we have taken equal to tan of 50 degree. Tan of 50 degree. This means like it is 1 plus tan 70 degree into tan 20 degree plus tan 20 degree is separated. Up to this we have reached. Of this value are to substitute. Now let me put what is value of tan 50 degree. 70 degree. Tan 70 is tan 50 plus 20. With that value I have put here. 1 plus tan 70 degree is tan 50 plus tan. This that means tan 50 degree plus tan 20 degree. Divided by 1 minus tan 50 degree. Okay, into tan 20 degree. Tan 20 degree and into tan 20. This is the value of tan 70. We have substituted this. Okay, and plus tan 20 degree here. This is the. Okay, now if the digit comes out to be that, let me check it. Tan 20, tan 20, okay, tan 50, tan 20. Okay, let me take this LCM. This is tan 50 degree. We have taken common. It will be as LCM 1 minus tan 50 degree into tan 20 degree. It will come in the numerator here. This LCM plus 20 into this. This is tan 50 degree into tan 20 degree, tan 50 into tan 20 degree. This is with plus sign, plus tan 20 into tan 20, which is tan 20 degree whole square. Tan 20 degree whole square. Divided by 1 minus tan 50 into tan 20. Okay, so this tan 50 degree negative and this is positive. Cancel out. That value is 1 minus tan 20 whole square upon this. Okay, so let me take this here. So we are finding out tan 20 degree. I could do this in other way also. Let me take this method first. This is tan 50 degree. Here we have obtained 1 plus tan 20 degree whole square upon 1 minus tan 50 degree into tan 20 degree plus tan 20 degree in here. Now let us further solve. If I take this LCM, we will multiply with this also. Tan 50 is multiplied with this, and this multiplied with that. Let us then solve it. it will be tan 50 degree. For this LCM is multiplied with this. It will be tan of 50 degree multiplied plus tan 50 degree into tan of 20 degree whole square it was, plus this multiplied tan 20 degree 1 into this minus tan 20 degree whole square, again this is tan 50 degree into tan 20 degree whole square, this into this, and LCM divided by 1 minus tan 50 degree into tan 20 degree. This is LCM. We see here this value and this cancel out. Now this tan 20 plus tan 50 degree in the numerator. We have obtained this is tan 50 degree plus tan 20 degree on 1 minus. It means right hand side we have taken to this whole value. So this comes out to be tan 70 degree. This is 1 minus tan 50 degree into tan 20 degree. This is the same formula we have taken out. This right hand side after cross multiplication we took to this side. So this is equal to tan 20 tan 70 degree. Because this is tan 70 degree. It means tan 70 degree equal to this whole value equal to tan 70 degree. And so this tan 70 degree, which is this formula same. So this whole value equal to this. We have put here. Alright, after taking the LCM, opening this, then cross multiplying and solving that tan 70 degree equal to this, and we see here that this whole value comes out to be tan 50 degree plus tan 20 degree. Then 1 minus tan 50 degree into tan 20 degree, that means tan 70 degree. Left hand side equal to right hand side. This is the right hand side. Okay, same result tan 70 degree has come out. This whole, after taking both of them, tan 70 degree we took on the left hand side, then we cross multiplied. Okay, so tan 70 degree equal to this tan 50 plus tan, and this will be open then a plus b after cross multiplication. First we open tan 70 degree. Tan 70 degree equal to that value, then cross multiplied tan 70, then we took common tan 70 we separated, taking this tan 50 and this whole value, and we see that this comes out to be tan 70 degree. Left hand side equal to right hand side. This is how the question is there. Or any shortcut if I change, and if anybody who is not understanding this point, we convert the whole thing into sin cos. This is sin upon sin 70 upon cos 70. This is all to sin 50 degree upon cos 50 degree plus sin 20 degree upon cos 20 degree, and solve it. That can also be done. That will give us the same answer. Now let us take question number first 7, now 8 question. Question number 8, what does it say? Let me check it. Question number 8. Okay, now question number 8. Let me see that what does it say. If cot alpha cos cot beta, question 8 say if cot of alpha into cot of beta is equal to 2, then show that if cos of alpha plus beta upon cos of alpha minus beta is equal to 1.3. Okay, this is if cot alpha cot beta equal to 2, then show that cos alpha plus beta upon cos alpha minus beta is equal to 1.3. Okay, that's the solution. So we have what we are given here, cot alpha into cot beta equal to 3. Now if I write it as cos alpha upon sin alpha, cot alpha means into cot beta means cos beta upon sin beta. Always convert them into sin cos. This is 2 only. This is cos A cos B upon sin A sin. Now if I apply component of dividend, so this is 2 upon 1. Or this is, let me write, cos alpha cos beta divided by sin alpha sin beta is equal to 2 upon 1. Now applying component and dividend So what is that? This will give us cos alpha cos beta plus sin alpha sin beta upon, this is numerator plus denominator upon numerator minus denominator. That means cos alpha cos beta minus sin alpha sin beta. This is equal to 2 plus 1 upon 2 minus 1. Here it is 3 by 1 values. So here it is cos A cos B plus sin A sin B. That means cos alpha minus beta, because cos A minus B is cos A cos B plus sin A sin B. Here cos A minus B. That means alpha minus beta in the numerator. This is cos A cos B minus sin A sin B. That means cos alpha plus beta. So in case of cos, it is different. It is opposite, I mean. For plus it is minus, or minus it is plus. So this is cos A plus cos A cos B plus sin A sin B, that means cos alpha minus beta, upon cos A cos B minus sin A sin B, that means cos alpha plus beta. This is the value. This is equal to 3 upon 1. Okay, this is cos alpha minus beta upon cos alpha minus beta. This is the value. Now let me check it. So here, okay, same thing. Or we can just reverse it. This implies that if I take cos alpha plus beta in the numerator divided by cos alpha minus beta in the denominator, that means 1.3. Let's suppose it. This is cos alpha minus beta upon cos alpha beta equal to 3 upon 1. That means equal to 3. Just reverse this. You will get cos alpha minus beta upon cos alpha minus beta equal to 1.3. Then answer. What's your question here? Okay, so this is what we have. Question number, hence proved. We have proved this. Same answer is hence proved. Okay, so question number 8 we have done. That was the same question answer we have obtained. Okay, so using component of dividend is just the addition of this. So please, for this formula is used a number of times in differentiation integration also. But there was, I mean, a rare use of this, but it is come has also it has come here. That's why I've described it. What is component of dividend? With that, A upon B, if we write equal to C upon D, using component of dividend. That means A plus B upon A minus B equal to C plus D upon C minus D. This is component dividend. Both the same process. This denominator is added in the numerator. The denominator is subtracted from the numerator in the denominator. A plus B upon A minus B. This A plus B, that's C plus D upon C minus D. This is the component dividend formula. This is applied and the solution is obtained. Okay. Question number 9 now. Let me check it. What is question number 9? Ninth question is the 9th one. I always write down questions here so that the questions I always read and write here also, so that if it is not obvious, not clear, then I clarify here. So everything is okay, it's clear. Because otherwise I have to take the notes in and I'm reading the questions and solving. That is not proper. No, this is written here. If anybody want to highlight this, can understand that what is the question given here. If there is any mistake, I'll just clarify that this is a mistake here. Well, this is not challenging of any kind. I'm just writing the question so that easier to read them and write down here. So question number 9, prove that. Let me check it. Question 9 said to prove here. It says that prove that cot x is cot of x into cot of 2x minus sign. It is minus sign. It is minus sign cot 2x into cot of 3x, cot of 3x, minus cot 3x into cot x is equal to 1 here. Okay. Let me take it. Cot 3x, cot 3x, cot x, cot 2x, cot 2x into cot 3x, cot 3x into cot x. If I take cot 3x common, that will check it. Left hand side, if I take, okay. So this is solution we are doing. So if I take left hand side here, let me write it. This is cot x into cot 2x or cot 2x minus cot of 2x into cot of 3x. Okay, cot 3x minus cot 3x into cot x. Now what we see here is cot 3x and cot x. Let me take common. This is cot x into cot 2x minus, if I take cot 3x common from these two, it is plus plus. That will be okay. It is nothing but cot 3x application, so it is cot 2x plus cot x. This is the value here. Okay, cot 3x, cot 2x left over. This is the remaining cot x here. If I divide it by, if I put value of cot 3x, okay, let me take cot 2x plus cot x common out of these two. If I take cot 2x into cot x common again, we will left with, in bracket it is 1 minus cot 3x. Alright. Now cot 3x can be opened. Okay, so what is the cot 3x? Alright, this is nothing but 1 minus cot 3x. This is the value here. So if I, let me write first cot 3x is what? Cot 3x equal to cot 2x plus x. We can write, and this is equal to cot A Cot B minus 1, that is cot 2x into cot x minus 1 upon cot A plus B. This is cot 2x plus cot x. Because we know this cot 3x equal to this. If I cross multiply this, okay, cot 3x upon 1 is equal to this, suppose. If I cross multiply this is cot 2x into cot x. If I cross multiply, then we will get that. Let me check. So we have nothing to do. What we have to do, we have to find out what is cot 3x is. Let me take cot 3x, we have taken. Cot 3x we have just taken here, which is cot 2x plus x. Then we opened this cot 3x we have taken up to this point. But that this is cot 2x into cot x minus 1 upon cot 2x plus cot x. Cross multiply this now. If I cross multiply this, it will give us cos 3x into cot 2x. Taking a cross multiplication of this, we are having here cot 2x into cot 3x. This is cot 2x. Cot 3x into cot 2x first plus cot 3x into cot x. Cot 3x into cot x is equal to this value 1 into this, that is cot 2x into cot x minus 1. If I take minus 1 to this side and all these values to that side, we will get the same answer. Or this 1 we have taken minus 1 to this side, which is positive now. So here we get cot 2x into cot x positive, and these values will be negative. Minus sign is cot 3x into cot 2x minus cot 3x into cot x. We see here cot 2x cot x, this is cot 2x into cot x minus cot 3x into cot 2x minus cot 3x into cot x is equal to 1. And to only just open cot 3x and cross multiply, you will get the same value. Hence, proved that this whole value cot 2x into cot x minus cot 3x into cot 2x into minus cot 3x into cot x equal to 1. This is good. So cot 3x we have to open. Cot A plus B, we know cot A cot B minus 1 upon cot A plus B, cot A plus cot B. This is the formula for cot A plus B. Then we cross multiply and this one. Obtain, we are obtaining the same answer. Result is obtained. Hence the question number 9. Let me talk about question number 10. What does question number 10 say? Let me check it. Question number 10 is, let me check what is that. First let me clean this further. Okay, now question number 10. So these questions are based on sum and difference formulae of trigonometric functions. Okay, so that the topic is clear. I've taken these questions based on these sum and difference formulae, and some formulae which given on knowing, but they are applicable here. So that also I'll clarify if is there any question which is just out of the topic, and the topic later I'll clarify, but before that take the 10th question now. For question number 9 we have done. For 10th question first. Question number 10, we say that prove that what we have to prove here. To prove here that cos 4x plus cos 3x plus cos 2x, okay, divided by sin 4x plus sin 3x plus sin 2x is equal to, now here there is something cot 3x. Now it is cot of 3x. Cot 3x. Try to understand. Okay. Now in this case, a different kind of formula will be used. What is that formula? Now we have to just know what there are. These questions I'll take later. That if the question sin C plus sin D is given, then it will be equal to 2 sin of C plus D by 2 into cos of C minus D by 2. But is cos, just like cos, this is cos here. If it is cos of C plus cos of D, then it will be 2 cos C plus D by 2 into cos C minus D by 2. If it is cos C minus cos D, cos C minus cos D, it will be equal to 2 sin C plus D by 2 into sin, try to understand this, D minus C by 2. Cos C minus cos D is 2 sin C plus D by 2 into, the angles are added upon 2 into sin D minus C, not, or put here C minus D, then minus sin will come here, because sin is odd function. C minus 2 sin C plus D by 2 into sin D minus C by 2. If it is negative, then it is C minus D by 2. If it is positive, then D minus C by 2. And sin C minus D will be first 2 cos, and sin C minus sin D will be equal to 2 cos C plus D by 2 into sin C minus D by 2. These are the 4 formulae which still I have not discussed. I'll take them later, but these formulae, out of this, here we will use one of the questions here. So these are the 4 formulae which I'll take in the next lecture series, but just to clarify this question, this will be used here. That's why I've just discussed. I've taken this question here. Just to discuss this, let me take this question first. For the left hand side, let me take first, and after that I'll clarify that this is one of the formulae I have to use here, which I have just clarified, but I wrote it down, but still let me take a question. So left hand side, let me take a solution. So let me solve this question. Left hand side is equal to cos 4x plus cos 3x plus cos 2x divided by sin 4x plus sin 3x plus sin of 2x. Okay, this is left hand side. Now here, if I take cos A cos B, let me take first cos 4x plus cos 2x first, these two, and cos 3x let me keep separate. Similarly, in the denominator, let me put here cos 4x first, then sin 4x first, and then sin 2x plus sin 3x separated. So this is sin A, cos A plus cos